A 2-kilogram block initially hangs at rest at the end of two 1-meter strings of negligible mass as shown on the left diagram above. A 0.003 kilogram bullet, moving horizontally with a speed of 1,000 meters per second, strikes the block and becomes embedded in it. After the collision, the bullet-block combination swings upward but does not rotate. Part A, calculate the speed v of the bullet-block combination just after the collision. Part B, calculate the ratio of the initial kinetic energy of the bullet to the kinetic energy of the bullet-block combination immediately after the collision. And finally, Part C, calculate the maximum vertical height above the initial rest position reached by the bullet-block combination. Part A, calculate the velocity of the bullet-block combination just after the collision. First, due to the conservation of momentum, we know that P initial is equal to P final. Now, we can solve for V final of the system. I've just wrote that mass 1 times the velocity of the first one equals the total mass times the velocity final. Now we can plug in our known values. For mass 1, we plug in 0.003. And for the initial velocity, we plug in 1,000. The total mass is 2 kilograms plus 0.003, which gives us 2.003 times the final velocity, which is what we are solving for. Now by multiplying, we can solve for V final. And by dividing, we solve that V final is equal to 1.50 meters per second. Oops. Now for part B, we must calculate the ratio of the initial kinetic energy of the bullet to the final kinetic energy of the bullet-block combination immediately after the collision. So first we must find what the initial kinetic energy is. So Ke initial is equal to 1/2 mv squared. And now by plugging in our values, 1/2 times 0.003 times 1,000 squared, we saw that the initial kinetic energy equals 1,500 joules. Now we must find the final kinetic energy. So Ke final is also equal to 1/2 mv squared, which equals 1/2 times 2.003, which is the total mass of the system, times 1.5 squared. This we found in part A as the final velocity, and by multiplying, we solve that the kinetic energy final is equal to 2.25 joules. So now we have both the initial kinetic energy and the final kinetic energy, and now we just need to find the ratio of the two. So we write a ratio 1,500 to 2.25, and by reducing this ratio, we find that it is 667 to 1 is the ratio of the final kinetic energy to the initial kinetic energy. Now finally, for part C, we must calculate the maximum vertical height above the initial rest position that is reached by the bullet-block combination after collision. So we know that TME initial is equal to TME final because total mechanical energy is conserved. So now, but also going along with that, we know that when the bullet is flying towards the block, it is 100% kinetic energy. And then once the bullet-block combination reaches its max height, that is 100% GPE. So now by plugging in our equations, we find that 1/2 mv squared, which is when it's all kinetic energy, is equal to mgh, which is when it is all potential energy. And now we simply plug in our values. 1/2 times, well, the masses cancel out. So we have 1/2 times 1.5 squared equals gravity, which is 9.8, times the height, which is what we were solving for. So we get that 9.8 times the height is equal to 1.125. Divide by 9.8. And we find that the height is approximately equal to 0.11 meters.